Hello and welcome. In this video, I'm going to show you how to use causal impact in Python, which was something that was developed in the same form as it was developed by Google in R. And it was such a tremendous job to make this package available for the Python version. And the case study that we're going to do is to honor the SpaceX launch that happened last weekend. And what we're going to do is we're going to take Elon Musk and we're going to use one of his, let's say, most infamous moments, which was when he smoked some pot in a live radio show around September 2018. And the key idea here is, okay, it was such a big thing. And was there actually any impact that it had on one of Elon Musk's public traded companies, which was Tesla, or not? Right? And that is what we're going to try to ascertain. We're just going to have a look at this very initial impact. So we're going to have a look at the 2 days. It happened between the 6th and the 7th. So we're going to put those 2 days as the impact period. In other words, that will be our treatment period. First thing that we're going to do is that we're going to import the libraries. So as a comment, import libraries. And to do this, it's likely that you are going to need to install 2 of them. So also as a comment, because you need to do this in your command prompt or your Anaconda command prompt, if you have, for instance, Spider. So you'd have to do pip install yfinance. And this one would be for you to be able to retrieve stock data. And then the other one would be pip install by causal impact. This one is the one that enables you to use causal impact. Moreover, now we need to actually import yfinance. And this one, we're going to do it right now. Import yfinance as yf. And as well, we are going to import pandas as pd. The next thing that we need to do is to define the dates. And let's say that we need a treatment start, this one for sure. And for this one, we will include, so equals to, and then quotation marks 2018, and then 09, and then 06, as well as the treatment end. So this one will be the 2018, 09, 07. So we'll have a look at what happened during these 2 days. Moreover, now we need some kind of training start. So now equals, we're going to do it since the beginning of the year. So 2018, 01, and then 02, because there are no stock trading on the 1st of Jan. And then we need some training end. Now equals, we do 2018, 09, and now 05. The last thing that we need is some kind of end stock, simply because when we get the stock data, the last date that we include is actually excluding. That's one of the things that usually happens in Python, that the last index is excluding. So we'll just state this end stock and we'll put 2018, 09, 08. This is it. Now we are ready to get the stock data as a comment. And we'll start by listing the stocks that we would like to take. And then as a list, so we start with the square brackets. And then we start with Tesla, which has the ticker name TSLA. Then we're also going to do Zalando, so zal.de. And then we're going to do Disney. And following that, a couple from the automotive industry, BMW.de. I'm using automotive industry simply because I don't think any of these things that Elon Musk did could have potentially harmed other companies within the same industry, as this was more a personal scandal rather than a company scandal. And then we have GM for General Motors, and then we do KHC, which is for Heinz. Next, now that we have listed, we go to our data set, and then we do equal, we go to our yfinance library that we have imported, and then we do download, open parentheses. Let's do Control I to see what's inside. So tickers, list, this is something that we have created. And then we have a start that we have defined, which will be this training start. And then we have the end, which will be this end stock that we have as well defined. And then lastly, we're going to do interval, which is here. So what is the time frame in which we want the stocks to be retrieved at? And for us will be daily. Let's start. So first thing will be our stocks. And then next we go to our start. Now start equals training start. And then comma again. Now we need an end, which will be our end underscore stock. And then finally we need interval, which equals, and then in quotation marks, we need 1 day. We have not run anything, so let's select everything and run F9. Here we go, 6 out of 6 completed. Let's go to our variable explorer. We have our data set. We have here a lot of stock data, as you can see. We have the adjusted close, we have the close, and we have the high, the low, and we'll have the open and some volume. We have here a lot of stock data. We need to pick one KPI, which for us will be this adjusted close. So that's the first thing that we need. We need to take out and just select some of the variables that we want. So getting only the data we want as a comment. Then we go to our data set and then equals again to our data set. We do .ilog to slice and then open square brackets. And then this colon states that we want all the observations, and then the comma to state that we are starting with the column selection. And then we do up until 6. And now why 6? If we go to our data set, we see that we have 1, 2, 3, 4, 5, 6. But overall in Python, index starts at 0. So arguably it would have been only up until the 5th. Nonetheless, because in Python, again, the last index is not included, so it is excluding, we need to go up until the 6th. And this is how we get all the data that we want. If we put here and select 6, it will choose up until the adjusted close of Zalando. Let's close this and let's run to see what happens. We see that our data set is now far smaller, but first of all, we have NAs, so this will be point 1, and then point 2, we have 2 rows when it comes to columns. So we have 2 sets of columns, and we don't need, because it's always adjusted close, we know that, so we can remove that. The first thing that we will remove is this unneeded level, and that is exactly what we're going to do. So what we're going to do is now, as a comment again, dropping unneeded level. And this is actually quite simple. Again, we go to our data set and then we go to the dot columns. So this is really to specify that we are just talking about the columns that are within our data set. And again, we need to do the same thing. So data set dot columns in order to do the transformation. And now we do the dot, and now we state the transformation, which is drop level. Open parentheses, and this would be it. Let's see. So our data set is like this. We have 2 levels here. We have our, again, our index, our stocks. If we run this, again, F9 to run, and then again, go back to our data set. And here we go. We drop that level, which had only the adjusted close. Next, we're going to get rid of this NAs or this NaN. So as a comment, getting rid of NAs. And again, we need to go to our data set. This is where we'll store the information. And again, we go to our data set. And now we state the transformation, drop NA. And this is about it. As you see, there's like this very clear way of structuring. The part on the left, this is where we make the transformation. So, or we create a new object, which for us is always the data set to make it more clean. And on the right, the first thing is where is that information, and then following that is the transformation per se. Again, let's run to see what happens. Again, F9, and we see that now our data set has no NAs. As a result, we are absolutely ready to go. One thing that we should definitely do is to ascertain whether our control group is good enough. And the way to do it is that we just take our training period and there we do a correlation matrix. And we need to make sure that we are dealing with somewhat comparable stocks. As such, we need to do some preparation before the correlation matrix, which is to create a data set of only our training period. As a result, comment getting data set of only the training period. Here you go. Next thing that we absolutely need is we create a new object, which should be dataset underscore correlation, and now equals. Again, we go to our dataset, and the way that we are going to subset this is that first of all we start with our square brackets, and now as we can see here we have 6 stocks and we have 6 columns of stocks, and over here we see that the size is also of 6. So somewhat this date can be considered to be excluded from our data frame. But that is not to be the case. What happens is that our date here is in the index. And that is exactly what we need in order to limit our data set to just the training period. And the way to do it is that since it is not particularly part of the data frame when it comes to columns, but rather is part of this index, we don't use the usual connotation that we're using before. For instance, when we're doing this .iloc over here to just select the columns, but rather we need to go to our data set and we need to do .index. Because this is where the date format is stored, and that is exactly what we need in order to subset our data. Now less or equal than, and then we do the training end. Here we go. Now let's do F9 to run. We go to our dataset correlation and we see that the very last observation is this 5th of September. And if you go and check, that is as well here, that is our training end, 5th of September. As a result, we are now absolutely ready to do the, as a command, correlation matrix. Here we go. And let's leave one more space over here. And the way to do a correlation matrix, it is super simple. Nonetheless, there is one thing that we need to do first, is that we need to increase the amount of columns that can be shown in the console. And that one we use pandas, and now we do set underscore option. Now open parentheses, and then in quotes, we go and do display, and now max underscore columns. There you go. And then we want none. So we want no limit over here. Let's do F9, and now then we do and go to our data set underscore correlation, and then we do .core. Here we go. Now let's run. So F9, and here we see our Tesla. So it is decently correlated with Zalando, Heinz, General Motors, and Disney. You know, honestly, I had quite some issues to find decently correlated stock with Tesla. And overall, these 4 were the best I've got. I just included here BMW as well, just for you to see that it doesn't work out. And since our key goal is to find the most comparable control group, what we'll do is that we'll get rid of BMW as a control group. And the key idea of this correlation matrix is to finally decide what is the control groups that we will decide. Hence as a comment, so finishing up control group selection. And let's just go up and copy this because everything that we want is already there. And the only thing that we need is to delete this BMW.d. So it is deleted now. Now, what else do we actually need? Because remember, this was a list, and there is something else that we need to do, is that in order to state that we want to create a data frame, overall here, we also need to do data set, and then we do double square brackets, and this way Python will know that we no longer want a list, but rather we want a data set that will be made from this list. And looking at it from an intuition point of view is, and if we forget about the double square brackets, it's rather that we go to our data set and then we create something with just the objects that were named inside our list. And let's also name it final underscore stocks. And this will be enough. So let's do F9 to run. And we see our final stocks. It is a data frame similar to our data set, but instead of 6 columns, which is a 6, it is a 5. And if you open it, we can see that there's no BMW over here. One last thing that we need before we do causal impact, which is to define the pre and post period. And this is just to aggregate the dates that we define in the very beginning. As such, we do pre underscore period and now equals, and then square brackets again. We do training start and then comma training end. And then the other one will be the post underscore period. And then again, square brackets. This will be the treatment start and then treatment end. And here we go. Let's select everything and run. And we can see here we have both our pre-period and our post-period, which is as a list. Now, finally, we are doing causal impact. And the way to do it is that, first of all, we need to, from causal impact, we need to import causal impact, because this one we have not done before. Next, we need to create an object in which we'll store the results of our causal impact, which we'll name causal impact. And now we do causal impact and then open parentheses. Let's do Control I just to have a look. And if we look at it, we need some data. This will be mandatory. Now pre-period as well, we have just defined it, as well post-period. Next, we have some, model, alpha, and then some other arguments. And because these are all optional, we will skip them. As such, we do data, and data equal final underscore stocks. Next, it is our pre underscore period, which equals pre underscore period. And then finally, post underscore period equals post underscore period. Now we're absolutely ready. Let's select everything and run. Now there are some errors over here. It is all about to do because we have irregular time index. Just to give you an example, if you go to our data set over here, we see that we have here the 5th of January and then goes to the 8th. So this non-regular time index makes it so that there is some errors. Nonetheless, it is a warning, and what happens is that causal impact compensates for these warnings with some kind of preset arguments. Now that we have done this, now we can finally have a look at the results. So as a comment results, and we're going to print and now impact.summary. And if we do F9 or to run, here we go. Let's also increase the size of the console to have a better look. There is a column for average and a column for cumulative. The one thing that I would highlight is that we cannot look at cumulative because stock price is a relative measure. As such, we can only look at the average. And looking at the average, our focus is on the absolute effect and the relative effect, and as well with our statistical significance. And we see here with 0.01 that is very, very statistical significant. And we can see as well from the confidence interval in which they're always negative. In terms of absolute effect, it was 29 euros or almost 10% of the value. As such, what happened with Tesla is that during those 2 days, it lost 10% of its value. Now, the question is, how much is this actually? Now, I went to check, and in stocks, so the amount of stocks that Tesla has is about 200 million. Go F9. And now if we multiply our absolute effect, which is this, 29.01, but let's round up to 29. And then we do times stocks over here. And if we do F9, now we can see that it was 5.8 billion, now closing in on 6 billion, which is a very decent amount to be lost in just over 2 days. Now, of course, there may have happened some kind of rebound in the next few days. There have also been, in a very ironical way, some kind of positive long-term effect from the doobie, but this was not the goal of our analysis, and the focus was really on this, very short-term event. As such, if you ever see some kind of CEO from a big company smoking pot or smoking a doobie on very live radio, please do immediately short the stock position, and you're bound to make a lot of money. This is it. We looked at on how to use causal impact in Python, and as well we solved this Elon Musk's case study. If you enjoyed this, I do go through a much more detailed way in both the Python and R version, and together with a lot more econometric techniques in the Udemy course below in the description. So if you enjoyed this, please do check it out in order to see if you also would like it as well. And I look forward to seeing you in the very next video.